Defining ray tracing in graphics. Ray tracing is a rendering technique that simulates the behavior of light as it interacts with objects in a virtual environment. By tracing rays of light from a virtual camera, this method produces realistic lighting, shadows, and reflections, creating graphics that closely mimic real-world visuals. How ray tracing works. Ray tracing calculates how light rays travel, bounce, and interact with surfaces in a scene. It considers factors like material properties, transparency, and light sources to determine how each pixel should look. This process creates natural effects like soft shadows and realistic reflections. Lighting and shadow accuracy. One of ray tracing's strengths is its ability to generate accurate lighting and shadows. Unlike traditional methods that use pre-baked lighting, ray tracing dynamically calculates light interactions. This leads to soft, realistic shadows that adjust based on light sources and object positions. Realistic reflections and refractions. Ray tracing excels at rendering reflections and refractions. Whether it's a mirror's precise reflection or light bending through water or glass, the technology calculates these effects accurately, adding depth and realism to game environments. Ambient occlusion enhancements. Ray tracing enhances ambient occlusion, the subtle shading effect that occurs where objects meet. This creates more realistic depth and texture, giving game environments a lifelike appearance by mimicking how light behaves in tight spaces or around objects. Dynamic scene adjustments. Unlike traditional rasterization, ray tracing adjusts dynamically to changes in the game environment. Moving lights, shifting objects, or altering camera angles instantly affect lighting and shadows, offering a more immersive and interactive experience for players. Hardware requirements for ray tracing. Ray tracing is computationally intensive, requiring powerful GPUs, such as NVIDIA's RTX series or AMD's Radeon RX. Hardware acceleration is crucial to achieving real-time ray tracing in games, as the process demands significant processing power for complex calculations. Ray tracing in modern games. Games like Cyberpunk 2077 and Minecraft RTX showcase the transformative impact of ray tracing. These titles use the technology to create stunning environments, with lifelike lighting and reflections that elevate visual storytelling and player immersion. Balancing quality and performance. To make ray tracing accessible, developers offer hybrid rendering techniques. These combine traditional rasterization with ray tracing for specific elements, like reflections or shadows, balancing graphical quality with performance for smoother gameplay. The future of ray tracing. As GPUs become more advanced, ray tracing is becoming a standard feature in modern gaming. Its potential to deliver unparalleled realism continues to grow, promising a future where games achieve visuals indistinguishable from reality.